Welcome to everybody joining the session. This is a session for understanding SMS call flows in regard to the SIGTRAN challenge. You can introduce yourself in the chat. If you're a student, tell us what you do, what year you're in, and if you're a professional, you can let us know where you work and what role you hold at your place of work. I'll let Jonina take over.
Yeah, but maybe before Jonina takes over, sorry, we'll cut you short. The key idea, we have a few people from telecommunications professionals. I think we have Edwin, who is with us, who has introduced himself. We are also expecting Mike Odongo and Isaac Tunya from Telcom Kenya. And the whole idea today is to ensure that the people who are working on the challenge can transition now from understanding the architecture of the GSM architecture, which they took us through last week, and also SS7 architecture. They were able to take us through the SSPs, the SCPs, and the STPs, those who are there. And they went ahead and demonstrated their understanding of the SS7 layers, dealing with MTP1 up to 3, SCCP, TCAP, INAP, ISAP, all those things. They were able to demonstrate what those layers do. And they were able also to take us through SIGTRAN, which is basically a way for us to bridge the traditional SS7 messaging to be carried over IP. So one of the things that the judges who were there last week mentioned is that in the presentation, they didn't see the call flows, especially for the SMS call flows. So the objective today is to be able to go through the SMS call. The objective is to be able to appreciate the SS7 call flows, SMS call flows. So the young guys will take us through what they understand. The objective, Edwin, Isaac, Martin, and we also have Grace, who is in the call, and any other telecommunication professional in the group. I've seen some Manyona, is for you to just supplement what they have, so that at the end of these, the people who are presenting and the people who are in the audience can actually move one step further to understanding what happens when the messaging, when we enjoy our SMS services. So that's it. I don't know whether there is any question, Edwin, in terms of the expectation. So we expect you guys to supplement in case they miss out on anything. Please help us highlight. In case they need to focus on something, also help us highlight that. Towards the end of the session, I'll also take a few minutes to just show them how to move on in the next phase, where we are supposed to write programs that decode and encode these protocols. So, Marlene, over to you.
So we have started the presentations on the SMS call flows. So Jonina will be taking us through that for group 4. And Jonina, if you're ready, over to you.
Okay, thank you, Marlene. I'll start with SMS. SMS is the acronym for Short Message Service, and it's used in sending text messages from one mobile device to another, or the mobile device, or even from mobile to a computer. And SMS, it's not real time, like it's not real time service, meaning that when you want to send an SMS, first it gets transmitted and stored in the SMSC, and then from the SMSC it is sent to the receiver of that message. So that makes it not a real time service. And for the working of the SMS can be transported using the signaling channel, and when the GPRS is not activated, but also SMS can be used, can be transmitted through the traffic channel when the GPRS is activated. We have seen for the SMS, it's non-real time, but for the voice communication is real time. I'll do a little bit about the working of the SMS. So when a sender, let's say sender A, user A wants to send a message to user B, you've seen it that it has to pass through some maybe for now, when you want to send from user A to user B, the SMS is first sent to the SMS gateway, then to the mobile service provider, and then the message is transmitted to the receiver. So it's not sent directly from the user to the receiver. There are other portions which it have to pass through before it is sent to the receiver of that message. There are different types of SMSs. They are categorized into 4 categories. So there is person to person, and application or advertiser to person, and person to person and internet to person. So we'll have a look at each of the category. So for the person to person, as the name suggests, this type of SMS is sent between 2 mobile subscribers, and from user A to user B. And so this is that type of SMS. And if you're in the same GSM, so when the message is being transmitted from mobile A to mobile B, if you're in the same GSM, they will use the same SMSC. But if you're in different areas, your SMSC for mobile A will send that message to the SMSC for mobile B, and then now the SMSC for mobile B will send it to the receiver for that message. That is person to person message. And application or advertiser to person. In this type of SMS, when let's say an advertising agency wants to send an advertisement to some people, the advertising agency will communicate with the service provider, and then the service provider will send the ads or the adverts to the mobile subscribers the subscribers they have registered in that service operator. That is for the application or advertiser to person SMSs. And person to network, the content provider will provide details such as ringtones, and then they have an agreement on the charges for both, and then the service provider will give out the shortcodes to the content provider. That is for person to network type of SMS. In the last type of SMS, and that is the internet to person. In this type of SMS, few websites will allow net users to send SMSs to the mobile subscribers from the internet. So that's in the internet to person. That's how it happens for the SMS, for that type of SMS. So this is the main part, the SMS MO and the MT call flow. So you've seen when a user, in this case MSA, mobile subscriber A, wants to send a message to mobile subscriber B, there are many parts that message will have to pass through before reaching to the mobile subscriber B. So when the SMS is sent, first it will go to the SMSC, and then when the SMSC receives that message, it will provide a feedback, an acknowledgement to say that to the MSC to say that they have received that message. And then when now the SMSC has the message sent to the message subscriber A, that SMSC needs the details for the mobile subscriber B so that they can transmit that message to mobile subscriber B. So first they'll have to ask for the details from the HLR for the details for mobile subscriber B. And here you can see the message is sent to us for the information details for mobile subscriber B, and then the HLR will respond with the details for that mobile subscriber B. Now the SMSC has the message and now the details for the mobile subscriber B. So now the SMSC can now send the message to mobile subscriber B directly. So after receiving the details, the information details, the SMSC will send the message to MSC for that mobile subscriber B. And when mobile subscriber B receives the message, an acknowledgement will be sent back to the SMSC to inform the SMSC that the message has been received. And when the message is received, after the SMSC received the delivery report, the SMSC will in turn send a status report to the MSC BLR saying that the message message sent successfully, and then the MSC can send back to the SMSC an acknowledgement for receiving that message. So that's how the MO and the MT call flow works. So you can see from this diagram, the MO and the MT call flow, there are two parts for the mobile originating part and the mobile terminating part. So when the message, when mobile subscriber A sends a message to mobile subscriber B, the message, the SMS, will go through the two phases, the mobile originating phase and the mobile terminating phase. So those are the phases I've explained. So the mobile originating, the first phase in SMS traveling from originating mobile subscriber A to the SMSC. So mobile originating from mobile subscriber A to the SMSC and the terminating from the SMSC to the mobile subscriber B. And so that those are the steps followed, the steps I've explained before. So there is SMS versus MMS. SMS, they are the short message service, and MMS, they are the multimedia. They are the large, maybe videos, photos, such. So the maximum size for SMS is it can be 16 or 140 or 70 characters. And when sending an SMS from mobile subscriber A to mobile B, it's not necessarily that the SMSC will find the mobile subscriber B on, like the mobile, it's not necessary that the mobile is on or reachable. So in cases where the mobile is not reachable, the SMSC will store that message and then will later send it to the mobile subscriber when they come online. That's why even when your phone is switched off, when you switch on, you will receive those messages because the SMSC had stored that message for you. And same to the MMS. MMS is for multimedia messages, the large messages, which include the picture, video, voice. And maximum size of MMS can be 300 or 600, depending on the MMS standard. And it's the same. If the network finds the device not reachable, it will first store the message and then it will deliver the message later. And if it's reachable at that moment, it will just deliver the MMS message to the device. So the SMS protocol stack. Text, but either it's whether it's an SMS or a multimedia message, MMS, it will be sent from one mobile to mobile device to the SMSC, and then the SMSC will then forward it to the mobile receiver. It can forward or it can store depending on the status of the mobile device B. It will store if the mobile device B is not reachable, and it will just forward if the mobile device B is reachable at the moment. Yeah, that's what we worked on for the SMS call flow.
Well, Janina, thank you so much.
Yeah. Thank you, Janina. On behalf of Marlin, I'll take over. For those who do not know me, my name is Kerry Kimani.
Maybe, Kerry, one thing that I would mention, because I know we have a very short time, and I hope Edwin Samanyona, sorry to ambush you, I've seen you there. So we might request you to give a a comment, and Isaac Tunya. But the key thing for the guys who are presenting, if the first group has presented something, maybe you could highlight what is missing or something that probably you think you could explain differently, so that we save on the time. I know we had a number of groups, so in the event you guys the other previous team has talked about something, you can skip and you just focus on maybe the addition to the call flows. Yeah. So Kerry, I guess you can welcome the group to, is it group? Yeah.
So
I've also been notified that my good friend Tan Opiata is here. Karibu sana. So we might also put you on the spotlight in guiding the team on any additions they need to focus on. Yeah.
Asante sana.
Yeah. Okay, so group 5 will present now. I understand Amos is on presenting. So Amos, I welcome you to the platform.
Okay. Thank you. Thank you all. Good evening. Hope we are all doing fine. Yeah, I think Joanina has explained several things that we already covered in our discussions. I don't think whether there is anything I will add. So I hand over to you, Seri. Thank you.
Okay, thank you, Amos. Now we'll have something from the panelists. I think we can start with Isaac. So Isaac, if you have anything to say about the presentation, please, you're welcome.
Okay, thank you. Thank you. I hope you can hear me.
Yes, we can hear you, Isaac.
Yeah, first of all, I just want to appreciate the presentation. I think it was from Joanina.
Yes.
Yeah, it was quite clear and simple. Yeah, the call flow was okay. The understanding is not bad. Maybe the only thing we could add on to it is when you're talking about communication between now the mobile phone, the MS, sometimes they call it the terminal. When it's sending the SMS, for example, the MO leg for the SMS that she described, maybe you need to understand that at that first instance, we are interacting with the MSC stroke the VLR. It is only helping to identify, checking on the status of the number that is trying to send the SMS in the network, knowing where it is, how it is latched to the network, whether it's on whichever MSC, it is at the VLR that has the information that we require for the particular subscriber that is sending. So it's like a confirmation is done there. And also you realize that whenever we are doing a MO SMS charging, it is at that instance that also that check is done against even an OCS or an IN somewhere. It is at that instance because sometimes if we are charging, for example, a short code, it is, or even a P2P SMS as explained, you realize that it is at that point that the checks, authentication checks are all done against the building systems before the SMS reaches the SMSC. Maybe she needs, she's already explained, but she needed to cover that also. And also, there is the other part when she was discussing about when somebody is not available in the network, whereby now there is a store and forward mechanism that is done for the SMSs. Maybe it was not so clear, but we realize that when somebody comes back to the network, when the network detects that this person is back, there is a functionality called the alert AC. It alerts. It's an alert AC. If you Google it, you'll see it. Alert AC is a way the core network informs the SMSC that so and so who was off air is now back to the network. It is what does the communication. It is what what helps in the communication between the SMSC and also the core network part, be the MSC or the HLR, to inform them that now this guy is available. Now you can originate the SMS to them. I also, maybe that is what I can say for now, because I expect that maybe more, I don't know whether there will be more time, because I don't know whether she's not explained in the diagram on how we are connecting to a third party, maybe a content provider, like for this case, let's say Meliora connecting to this particular network. The protocols that are happening between that, you see, whether it's SMPP, whether it's HTTP, between the third party and the SMSC. You know, there is the communication for the A to P, and also there is the communication for the P to P. They are quite different in protocols, because maybe one uses the SS7, like for example, the P2P when you are sending the SMS to the phone, but also like for SMPP for content provision, like if I have a content provider like Meliora in this case, maybe it would be connecting via maybe an SMPP interface, or it is coming via another third party. It can even be an SDP platform that connects via an HTTP, then connects to the SMSC, or even a subscription manager, depending on the network you are sitting on. So I had a feeling that those ones, maybe if they have time, maybe they will include them sometime later on. And maybe other issues around that, about the integration, maybe that one you'll be able to check on later. And I think that is what I can say for now. Maybe if we get some more time later on, we'll talk of a few things like on the bulk SMSing and the rest. And also the security measures like controlling the spam SMSs and the rest. Thank you.
Thank you, Isaac, for those comments. I'll now welcome another panelist. Let's have Edwin. Edwin, over to you.
Hope you can hear me.
Yes, we can hear you, Edwin, now.
Okay. Thanks. So I think Isaac has touched on most of the items that probably also have wanted to comment on, but I think he's mentioned about, so in the call flow, if probably you can, I don't know who was presenting that, if probably that presentation can be brought back.
Yeah. Jonina, you can share the call flow slide. You leave it.
On it. Okay.
You can share the screen.
Yeah. Here. So I think that there are certain things I think Isaac has touched on. Normally, when we provide these services, different operators provide the SMS service. There is a billing part that is also happened. So it will be good to probably enhance this call flow so that you probably also show where the billing platform comes in. I think Isaac mentioned OCS, because when you send that message, basically when you send a message, you will realize that the message leaves your handset, and before your handset probably indicates that the message has been sent out, there's something that happens in the network. Basically, the SMSC platform interrogates the billing platform to check if the mobile subscriber A has sufficient airtime to send that message. If mobile subscriber A does not have sufficient airtime, then that's where you get the mobile A complaining that message has not been sent or something close to that, or if there's a problem with the network. So just be important to indicate that. And then the other thing is, I know it's been mentioned about the protocols. It will also be good to know the protocols that are at play in all these interfaces that we are talking about. And I think most of the protocol here is a map. So you also need to look at, I'm not sure if you probably had a chance to look at the stack, the SIGTRAN stack. Just
Yes.
look at yes, so that you also know that the messages you are showing up there, at what layer do they at what layer are they in, whether it's something in TCAP, in MAP, and so forth. And then the other thing is there's a diagram you had shown on SMS protocol stack. Is it slide 14? Yes, here. So you need to relook at this, because I'm seeing there is when you go to the link layer, there's of course you have the link layer, you have the relay layer, the transfer layer, and then on top you need to have the SMS application layer. Now that is normally transparent, but where you communicate end to end. Basically the transfer layer and the application layer, because on the mobile handset you also have an application that reads that message. And then you also need to know if say you are a developer and you want to develop an SMS application of these layers, which is the most critical layer probably for you to understand better. So you need to investigate on that. Probably investigate how the transfer layer is important for someone who wants to develop an SMS application. Then the other thing is basically the presentation has been good, so I think there's only room for further improvement, but those are the key highlights for me. The other one is so when you do this presentation, you also need to look at the future. I know you touched on MMS, but we still have few customers who use it, but it's on sort of MMS is on its deathbed. So for SMS, you need to look at the future basically. So right now we are talking about 4G. How is SMS sent over 4G? So probably investigate that, how we're able to send SMS over 4G, and then look at stuff like if you have a handset now and you have these Android phones, you'll realize that I can send you a message without necessarily going through an operator's SMSC. So how is RCS coming on? So I think that is just the future. You just need to look at where SMS is headed. I think that is all from myself for now. Back to you, Kamochu. Is it Kamochu?
Yes. Yeah, maybe I don't know whether I've also realized there is Thomas Njoroge, who is also from Telkom Kenya. So we have some, I believe, Michael Dongo, Anyona, Tan, Opieta. I don't know whether there is any one of you who would like to make an addition or correction, and you can say hi in case you have one.
Hi guys, this is Sam Anyona. Can you hear me?
Yes, we can hear you.
Yeah, so I think I was going to make a comment on the protocols, but my colleagues have already made those observations. Mine is to commend the presenters for doing this research. It will help you to a great level once you come to applying your skills, because this understanding, believe me, there's quite a number of people who are in the industry and they don't have it. So kudos to you for that. Thank you.
Asante Sam. Maybe just a fun fact. Sam's father was my head teacher. Yeah, so Anyona is a special name to me. Yes. And of course, he used to talk about the son, who happens to be Sam. So Tan, and I don't know whether Mike Odongo is around, whether there is something that you can add. Yes.
Thank you. Michael Odongo. The only thing I may mention is with regard to the call flows, one other aspect you can consider is, okay, I know in addition to all this is the aspect of integration. Usually we may take it for granted, but you find that at most levels or at you may have very much with the network, maybe from an integration. So that means that either you could be having an app somewhere that is interacting with users and you're supposed to send an SMS. So you may be interested in understanding how would you integrate with the network. So as in take it down to the user, take it down to an application to now appreciate those other aspects. So because that normally comes very late, but if you can have that at this stage, you'll be able to do more with the different services that you have, because most of the services you have are just legacy services, but the users are the ones that give that service life. So you can also give that angle that it's not just SMS. The question is, how does SMS help you do two-factor? How does SMS help you tell someone your balance is 10 bob? Something like that. So yeah, you can challenge yourself in that angle.
Yeah, thank you, Mike. I don't know whether
if I can. Okay, this is Stan. I think the presentation was, I'm impressed with the presentation. It was okay, excellent. And maybe just to add, in terms of, I think the team has mentioned about charging. Just needed to add that for charging, it's not like it is fixed that it's in the flow where it has to be done on, let's say, on MSC or SMSC. There's flexibility depending on the implementation. We have flexibility where it can trigger on MSC, for example, or on SMSC, and depending on the charge, the message type, it can trigger charging on MO, on MT, or any other message that you wish to trigger charging. That's the only thing that I saw that I needed to add. Thank you. Otherwise, I think the presentation was excellent.
I don't know whether there is anyone else who has been locked out. And I think Polycarp, I don't know whether your group, everything that you wanted to say has been said. It's good to give you guys a chance also. I don't know whether it was Polycarp or Tabby. Yeah.
Oh, it was Tabby. The presenter has already covered most of what I wanted to say. For mine, I was just giving examples for each type of SMS.
Okay, I think we can, just because of time, what we'll do is I will mention that, because I also noticed that it's good when you say A to P, you need in today, how many people received an A to P message? I think making it practical, I'll mention that, don't worry.
Oh, okay, no worries. If you're going to do that, then everything is covered.
Okay,
thank you.
Yeah. So thank you guys the people who have joined us. I believe that seeing is believing. So I'll take just a few minutes to help guys transition a bit. I don't know whether you can see my screen. So the key idea, and I had, I think it was either Mike or who talked about the integration and how applications connect. There was someone who had mentioned that. I think the task for this challenge is for guys to just support MT. MT is slightly more complicated than MO. And by now, guys, you know what MO is, mobile originating or originated. So when you send a message to your friend or to a shortcode, you're originating the message from the mobile station. So that's a MO. But of course, when you have P2P, there is one leg, as Jonina took us through. We can see one leg, one person is originating, but the other person is receiving, or the message is being terminated on their handset. So a MOMT, when you send an SMS to the KCSE shortcode, that's MO. When you receive an SMS from your friend, that's MT. When you receive an SMS from your bank, that is MT. If you receive an SMS from your friend, that's P2P. But when you receive an SMS from your bank, that is A2P. So those are very common. I know Jonina talked about many other categories, but when you hear A2P, then it means you are receiving from maybe your bank transactional alert or one-time password. The flow is, the app is sitting there. The app sends the message to the SMSC. Someone mentioned, yes, we are dealing with SIGTRAN, but when you're connecting your applications, developers don't talk SIGTRAN. Our developers today, they talk either HTTP or SMPP. So we can see this leg here. Once the message is forwarded to the SMSC, the work of the SMSC is to ask the HLR, which we say the HLR knows the location of the people who are on the network. So if you switch on your phone, the HLR has a profile of where you are. And when you say where you are, ideally, it's the switch that is serving you. And a telco can have many switches. Like Safaricom could have a switch in Thika, could have another switch in Kibosto, in Kisumu, another switch in Nairobi, and many other places. So if you're connected from maybe Nyeri, there is probably a switch that is serving you, and the network knows that, but the SMSC doesn't need to know. It just needs to talk to the guy who knows. And that's why we are saying it's send routing information for SM, as Jonina described. Now, of course, when you're asking for send routing information, if I ask you guys what parameter must be included there, we must always include the number as part of the parameter. So my work here is pretty short. It's just to add whatever that you guys have had and help you guys move to the next stage. Now, as we discussed last week, after we do these call flows, the key idea is for you guys to go and deep dive into those protocol stacks. So some of you need to understand these SCCP, M3 UA, because we are IT guys, so we operate on the SIGTRAN side of things. If you are pure telco guy with a special hardware, we operate on the SS7 side of things. But for us, our interest is this side of things. I think someone has already mentioned that SMS uses MAP protocol or mobile application part. So, but mobile application part doesn't come alone. You have to carry it over TCAP, and you have to carry it over SCCP, and you have to carry it over M3UA. We, the developers, as I said, we know how to create sockets, and we can receive bytes through the socket. So SCTP is our thing. The only thing we need to know is how to decode all these parts. Now, my work is very simple now, is to just show you a sample dump and to show you what parameters are included there. So I'll go straight to, I will show you guys a dump that has this thing. SRI, you get SRI response, then you do forward short message, and then you get forward short message acknowledgement. So the key idea is I have a dump, and I hope you guys can see it. And this has been provided by some of the people who are willing to help you guys. I think Collins Olwatch last time said that it's important for us to actually see those dumps. So I have shared a dump, and I can tell you, although this diagram might not, this dump that I have captured does not show you things very clearly. One of the things I can tell you is that this thing that you're seeing here coming from 127 to 45 is actually what we call the SRI for SM. We'll expand it together. And then this line here is the response. And after that, we forward the message to the switch. And this line here is invoke forward SM. For those of you who can see, this is MT forward short message. So this is it. And then the other line is basically whatever that you get there. So my work is just to demonstrate this and relate it with this and help you guys go deeper and read these documents here, whether it's M3UA document, whether you're reading this, the TCAP message format, or whether you're reading this is TCAP or you're reading a CCP message format, because at the end of it all, the challenge that we have at hand is actually decoding challenge. The rest of the stuff is very, very clear, but how can you initiate an SRI? So I will go very fast to this, and I will just expand this thing for you. So what happens is we said that a SIGTRAN uses, if you go to M3UA, then you will find that it uses point codes. There was someone who told us that nodes within the network are identified by point codes last week. So we have this source originating point code and destination point code and many other parameters. So the work of the guys who will study this protocol called M3UA, which you're supposed to study in the next 1 week, and you have the document here, which we shared with you guys. So you have the M3UA document. Your work is pretty simple, is to come and tell us that an M3UA sort of allow me to call it header, although sometimes it's not very accurate to call everything a header, but since you guys come from IP, it's easier, has all these bytes, and this is what each of them means. Then other guys will study a CCP and they'll tell us a CCP message starts with 1 byte, and the first part it talks about the message type, and the second byte is split into 2. One part tells us the class and the other one tells us about the message handling. And message handling can take these different values that you need to do. So how do you, and then later you'll talk about the mandatory parts, the optional parts, and mandatory variable and mandatory, optional, that is. So all these things you're supposed to break them, but you'll break them according to the documents that we share. So let me show you an SRI, because this is the most important thing for us. It rides on TCAP. So if you open TCAP, you'll see it's a transaction begin. So don't worry about that. These are things that you're going to dive into. But I'll show you here that here what we are doing is we are basically asking the network. If I come here and expand this, you can see we are asking for the location of this guy. We are asking that the SMSC is this, and we are asking for the location of this guy. And this is what we call now an SRI. It has the mobile number, you're checking its location, and it also has the SMSC that is asking for that information. And all these parameters are defined according to the standard. So you can see the parameters for an SRI. So the invoke ID, because it's part of the TCAP conversation, don't worry. And then you have an operation code, and then you have the mobile number, then you have the SMS center number. Now, once we have that, we get a response that comes back, and the response tells us that these are the messages, and it tells us that this guy is essentially, so this tells us that the guy is actually being served by the switch 610. So remember here we are asking for send routing information for this guy, this number that 062, and then we get a response that tells us the customer is in switch, the one that has 610. Remember last time we talked about in telecommunication, the addressing that is done is, we don't use IPs, we use either global titles or point codes, which we talked about. So here they're using global titles. Global titles are just like your numbers. And whenever you set an SMSC center number on your phone, that's a global title. And this is what we get. Once we get that information, what do? We forward the message to the network. So you can come here and open this, another request that goes to the network. And we come and forward that message. We have the message, we have the sender ID, and we have a lot of other stuff that we need to know. But the key idea is that we have the SMSC number, and we also have the the destination number. I'm trying to see where it is. Where is the mobile number that's supposed to receive the number? This is where Edwin, you're supposed to step in and rescue. But let me see. The originating address, the originating center number we can see. So essentially, the point that we are trying to make is that I think the mobile number must, you can see it.
Should be.
Sorry, what are you looking for, Kamuchi?
Just the number of the customer whose line is being forwarded to, or are they using the IMSI?
The destination.
Just go down to SMS TPDU, go down, SMS deliver, go down.
Yes.
Where you use, that's the originating address.
Originating is Safaricom.
Where is the...
This is an A2P.
Yes, this is an A2P, because you can see
the originating address is Safaricom.
And the destination?
Destination should be down there, further down. It's not there. User data, no, before you get to user data.
You can minimize this.
Address is there's an IMSI.
Minimize this SMS TPDU.
This one is coming from where? Is the calling? Who's calling? SMS. Oh, it's from the SMS.
Destination address. I think it's using an IMSI.
Normally, SRI, I think it's
a dummy.
It's a dummy IMSI.
I think that's
Which message is this? This is forward SM or SRI?
Yes, this forward SM. This is forward SM to the switch. It's this leg here on my diagram. This one here on my diagram. This
delivered. Then you should have been given the
B party.
That's the actual IMSI.
Okay. So the message we send the IMSI instead of, sorry for those guys who are wondering what IMSI is. Your number is MSISDN, the one that you call 2547XX. But on the network, the unique identifier of your SIM card is the IMSI. So on the network, sometimes you might find the IMSIs being sent. Yes. So I hope that makes sense. So the key idea that I wanted you guys to know is that these dumps are here. For those of you who do not have access, remember in this project folder, we shared this with you guys. If you don't have it, you can come and pull the traces. And I think there was one guy who Tunya talked about alert SC. E.g., when your phone is off at night and someone sends you an SMS, when you switch it on in the morning, there is a possibility of the HLR after you come back to the network to notify the switch, the SMSC center or the SMS center or the SC and tell them that this guy who was offline is now online. And then immediately the SMSC is notified. Then it gets all the messages that have been stored for you and they're forwarded to you. The forwarding is still the same. So you can see here the alert SC with acknowledgement. So there are dumps for that. And we have the SRI, which we already said what that is. Now, I know time is not on our side, but I will spare, I'll just allow you guys to, I'll just do a very small demonstration that we can know how to decode this stuff, because the challenge we have ahead of us is not easy. Understanding the call flows is important, but being able to receive, because ideally what you're supposed to receive is this part. And allow me to just copy this and I copy the hex stream, because remember you guys are developers. Developing is not about being able to use Wireshark. So you're supposed to receive something like this for TCAP. Yeah, so you're supposed to receive something like this. This message you are seeing there has every information that you need for you to develop applications that can generate these things and send them over the network. So the key idea is, how do we break this thing accordingly? And I'll open just a page now, and we will read briefly, the guys who are coming to tick up. Now, we will read briefly we are going to study briefly what TCAP does and the various parts of a TCAP message, and we are going to see how we can break our bytes into the parts according to this specification. So sometimes you might need to use Wikipedia or articles that are simpler to understand the function of what you're doing. So allow me to tell you guys that as part of the challenge, you're supposed to know the function of TCAP, the procedures that are supported on TCAP, the messages that are exchanged whenever you're dealing with TCAP, and the format of those messages. And the whole idea is to decode this thing and to encode these things for us to develop. It doesn't mean that when you're building a real application for production, you'll have to do these things, but the appreciation of these as a developer will allow you, even if you decide to adopt a stack, an open stack to do SMSC, you'll not have a hard time doing that. But for now, in our challenge, you'll actually have to decode this thing for us. So allow me to go and look at what TCAP says. So the TCAP is essentially, for those of us who have dealt with TCP/IP, there is something called ports within the networking and networked applications development. So on SS7 and SIGTRAN, they don't have ports. So TCAP allows us to have things like you can have a sort of a transaction where you can send a thing and you can continue and you can end. So that if you're dealing with something that is session-based, then applications that require those transactional kind of primitives can actually be built on top of TCAP. So I will not go through these things, but I'll go directly, and TCAP has 3 parts. You can read the document, and I think I can come here and just open a document and you can see what the documents talk about. These documents are not long. So the guys who will be dealing with TCAP, you have to come and study this thing. So the document says that for TCAP, I will just open a small section, and it says that a TCAP message looks like this. So you have the message type, which you have to decide. Now, if the message type is begin, then these are the parameters you need to have. If the message type is end, you must have this stuff. If the message type is continue, then you must have this stuff. If the message type is abort, then you can do that. One of the things that you'll note when you're doing an SRI, we used TCAP, but it was a begin. And then the response said end. So that's something that you need to know. But now, if I open the bytes for TCAP, you can actually see the bytes are here. So these are the bytes for TCAP. So starting with 64 at the bottom here. So you can look at 6451. But what do we mean by that? So the key idea that I want you guys to do is I want us to just illustrate how you break down the bytes briefly to look at how TCAP works like. Now, I will come to this. If you remember, guys, we learned something about tag length value, where we said we developers who deal with applications like HTTP applications, we always have JSON, sort of maps a key and a value, and we encode them nicely. But now, since we are dealing with bytes, or these are what we call binary protocols, we don't have the quotes and the semicolon or the full colon to help us separate this. So the key idea that you need to know is that everything has a tag, and the next thing is a length, and the next thing is content. The tag is X number of bytes, the length is X number of bytes, and the contents are what the length specifies. So I'll come here and I'll open this sample that we have here, and I'll come and look at the first thing. This is a tag. So then the next thing is the length. So this is the length. For those of you who know binary mathematics, 8 times 16, then you do, the 1 is 1 times 1. Hexadecimals. Remember, these things are hexadecimals. And 8 times 16, who can give us an answer? It must be 8 times 8 is 64, times 2 is 120.
8.
It must be what? 120? 128 plus 1 gives us 129 bytes. So essentially, you're being told that the whole of this thing is 129 bytes. And for you to believe me, so you have to come and copy all the way up to 129 bytes. That's how you decode. And I can select, I know these are nibbles, so don't worry. So I'll go 129 times 2, that should be 250 what? 258 nibbles. So if you're a developer, you just pick the first byte and then you go and look for 258 nibbles. Actually, sorry. Let me just pick the whole tick up thing again. I hope it was this one. I copy hex string and I put it there. Sorry, did I copy the tick? I copied the wrong thing. Hex string. Then I come here. Wow, I think I had copied the wrong thing. So it's, the tag is 62. Now tag 62 in decimal, this is in hex, yeah? In decimal, it could be a value. And tag which is 62, if you go to tick up document, it will tell you what 62 represents. So this is what you're talking about. You read the document so that they can tell you what the tag represents. So you can find that if you say, like, let's say we have you can look for the different tags that are there. So if you come here and you look at it's 52, then it could probably mean that maybe it's something. So you have to go and read that. Then the next byte gives the length. So the length here is 43. And for those of you who can do conversion, it's 4 times 16 plus 3 times 1, which is basically 4 times 16 is what? 64 plus 1, and it gives us 65 bytes.
Plus 3.
Huh?
Plus 3.
Or plus 3. And it gives us what?
67. 7
bytes. Now, if you come here and you copy these, you'll discover that 67, if they are nibbles, remember a nibble is 4 bits, yeah? How many nibbles are those? 132? 134, sorry. So essentially, if there was another tag, all these things, this is actually the value of this tag. So this is the value. Now, for you to figure out what this is, you also have to apply the same logic. And you come here and you have, again, this one, you break it into tags and all that. So here we come and say we have another tag. Yeah. And the tag is 48. Now, the length is what? You can tell us what's the length? The length is 4.
Yes.
Now, these 4 bytes, you have to read 4 bytes. And if it's 4 bytes, you have to think of 8 nibbles. So to square 8 nibbles, and you copy like this up to 8 nibbles. Now, this, for those of you, this is a value. And I want to go to Wireshark so that you see something about this thing. Essentially, if I go to Wireshark, because it does the magic for us, but remember, you as the developers, you don't have the luxury. If you're a support engineer, you just need to know Wireshark. Guess what? The transaction ID is 00A9D101, if you want to figure out from here. Now, what we've just done on our manual splitting, this tag is actually what we call the transaction ID. So tag 48 represents transaction ID. The length says we have 4 bytes. And out of the 4 bytes, we get this value. So that's what Wireshark did. But remember, us who are the developers, Brian, I can hear you responding. Your work is to split this and you tell us what the transaction ID is. I'll move on because now the first tag is over. Another tag that we have what is 6B. This tag 6B could mean something else. And of course, the length is 1A. For those of you who know 1A, 1 times 16 plus A is 10 times 1. So this is what? 26 bytes. And that gives us what? 52 nibbles. So I just copy 52 nibbles. Zikiisha, we know that that tag has ended. And I'll go all the way to 52 nibbles. 52 nibbles. For those of you who are wondering why I'm getting 52, I'm just checking at the bottom here. Yeah, so that gives us the end of another tag. So what is this value? This is the value. But what is it? Again, the specification document tells you. So you can go to this document, read, and tells you that a tick-up message starts with this and this and this and this and this and this. And this part, the first mandatory thing that needs to be there is the transaction ID. And then we get another one, we get another one, we get another one. And depending on the service that you're using, these parameters could vary. So if you're doing messaging, there are things that might be there and that are not there when you're doing USSD. But the key idea is the developers, and you guys are the developers, are supposed to split this. And I know we have passed our time, so allow me just to conclude in about 10 minutes. Then we have a 6C. Again, this is another tag. What does it mean? I don't know. The document says it. And then this is the length. So TCAP uses the concept that every parameter uses tag length value, or what we call TLV encoding, where one byte represents the tag and the other byte represents the length. And if the length says 5, then you just know that the value is 5 bytes, depending on the value on the length. Now, TCAP is the one, and when you go to the procedures for TCAP, it will tell you that, you must have a transaction ID, you must have an originating something, and all those things. Now, that's the work of this document. It's not a long one. Don't attempt to read this document without the dump. It will not make a lot of sense to you. So actually, for me, how I do it, I start with Wireshark, then I look at these parts, and I go to the document, trying to figure out what the document says about that part. If you read this thing, it's only 39 pages, and trust you me, it's 39 pages, but by the time you're done with the table of content, you're on page 6. And there are many other pages that talk about the reference documents. For those of you who are there during the engineering summit, Safaricom Engineering Summit, I was actually telling you guys, these documents are not too long. They are very short. Support engineers, Sam Anyona said that whatever call flows you guys are describing, it will shock you. Most of the telco engineers actually do not appreciate, and maybe some of their jobs don't require them to appreciate. But you're in a place where you can do this. If you can decode this, trust you me, most of the telco engineers cannot do this because they have not found the need to do so. But you guys need to develop, and that's why we are doing this. So how many bytes are this? 1F, so that I stop. Then F is 15, for those of you who know. So this is what? 31 octets, right? An octet is the same as a byte, by the way. And that gives us 61, 62 nibbles. I hope, yes. And we have 62 nibbles, and this is what? Value. But what is this value? The specification tells us. But if I come here, even if I don't read the document, I can actually come and see that the TCAP parts, the first part was the transaction ID, which we did. And then the second part, which has a lot of stuff, has the originating, this TCAP has things to do with dialogues and components. You'll go and read that a TCAP message is made up of a transaction part, a dialogue part, and a component part. What are those things? The specifications give you that. And even articles like these ones. And all these things are shared on this document that you guys are working on. Articles like these ones, they tell you what a part, what a component is. Just Google TCAP, SS7 TCAP, and you'll be able to find that. So, of course, the first part talks about this. And then the second part, which is this last part here, and I'll come and look at it. Let's see. It starts with A. I'll tell you for sure that this is the map request. So this is something to do with the dialogue stuff. And this is the map request, which is put in a format of a component in a TCAP message. So I know some of you might be asking, what are these components? Don't worry. The 39-page document will tell you what a component is and the various parts. Now, Wireshark has done this for us. So let me just come here to Wireshark, and you can see that as part of this now, for you to understand this value here, wasewa tick up kazi yenu imeisha. So here, for us to decode this message, to decode this value above here, we need to read the map specification. So in a grouping in it, this is another group that will be dealing with that. So the tick up guys have basically done much of your work in terms of the message format. What you need to figure out is the functions of tick up. Why do we even need tick up? SS7 would have worked without tick up. Why did we need it? What procedures are supported? What messages are supported? Please note, whatever is not necessary for SMS, you can ignore it for now. So if the guys who are doing SCCP, don't dive so much with connection-oriented SCCP messages. We don't care, because for messaging, we need connection less. And if you don't know what that is, you're supposed to go read the document and you focus on what is necessary for us. And that brings us, bravo. The key idea is always know that there is the bytes that you receive on the network, and as we are going to write socket services, because we can write a socket to send something over the network, we are going to decode these things and we are going to encode these things. So the hard work is for us to do this in the next 4 weeks. So you need to study the documents, you start decoding. The guys who did the first hackathon, you do not have a challenge. I'm happy to know that some of you are in the groups. So you are going to help your team members to ensure that they can actually write code that can split the bytes according to this format. And if you do so, we will actually simulate something like this. And I hope Edwin and Tunya will give us a chance to go and set up a small SMSC on their network. Yeah, they don't have to commit here, but we'll have to convince them as we continue. And Mike Odongo, that they'll give us a chance to put a small thing, and we see the SRI messages and all those things going around. So I've just demonstrated how a tick-up message looks like, and I've demonstrated how you can decode it. And the SCCP guys, you can actually come and break it. You see the format for SCCP. It says, the message code, the mandatory parameters, pointers to those mandatory parameters, and pointers to optional parameters. And essentially, if you open a SCCP part, you start seeing the message type, which is here, the class and the handling, which is another parameter, and then pointer. And these are the pointers that you're being told there. So if you read this document and together with the dump, you'll have a very good time. And you can know who is calling who and who is being called. And these are the two parameters that are, actually there are three parameters that are mandatory, variable parameters. The one that starts at 3, which is here. The one that starts at 14, which is here. And the last part that starts at 25. I know that might not make sense, but basically the tick-up payload. So you can see how the SCCP messages are carried within the SCCP part. So for those guys who are seeing these arrows here, and SCCP above it, there is tick up. This is essentially what you have here. Get Wireshark. You can go download Wireshark. It's that tool. And if you just Google download Wireshark, you do it. Some organizations will not allow you to install Wireshark because some of you can sniff on the network and make a lot of mistakes. So you might need to do it on your personal laptop if your organization policy does not allow you to download this. Once you download that Wireshark, you can actually come and get our traces. If you don't have access to these traces, Marlin and team will ensure that you get it. I don't know whether there is anyone with a question and whether this is helping you now to address the challenge in this part, which week 2 challenge, which is supposed to run this week, actually from last week up to next week. So we are supposed to have guys who can tell us, if I receive a byte stream of M3OA, M3UA, like if I give, let's say, Gionina, I just come here and copy these bytes, the hex stream, and I paste it and I send it to Gionina. Sorry, it's too big. Yeah, I think I need to copy from here. It has the whole thing. I can give this and Gionina can tell us which is the point code. Because you know which point code, you know, we already know where the point code is according to Wireshark, but can our developers decode? A point code is 4 bytes, 00003135. What to a hexadecimal, you know how to convert this into decimal number. And I can bet 3153 in hex is the same as 12627 in decimal. You can do the maths using the place values as we described earlier. So that is it. I don't know whether there is anyone who has a question, but the whole idea for this challenge, it's not an easy thing. Very few people in Kenya have done it, but I believe that if you guys work together in your groups, imagine we will be in a position to appreciate these things. And if you can break stuff, then I can only imagine the potential and the future that we'll have. And you can actually get a seat in Telcom Kenya where you can go there and showcase, and the engineers will be amazed. Sindio Tunya and Thomas. Yeah. Tunya has lingered me, but it's all right. Yeah?
I'm not sure if Tunya is still around.
Okay. But I believe that, Edwin, if these guys can come and showcase this, you can give them a seat. They come and just showcase that, and people will be amazed. Right, Edwin Tan?
I'm here. I'm here getting you clearly.
Yes.
Yes. This will be even learning for guys.
Yes. And if you can do this, you can do this for every protocol. Whether it's diameter, whether it's that SMPP someone mentioned, it works the same way. Most of them use tag length value. Some of them call it, variable parameter something, meaning that the value can, and you just need the tag or parameter ID code, the length. And using the length, you can know how many bytes you need to read until you get to the end. Group 1, Brian and Tim, are you feeling that you can dive now into this?
Yes.
Okay. And Polycarp and my sister Tabi.
Yes.
Okay. So
Yes.
please let's dive into this. It's a lot of work, but if you do it, we'll get somewhere. So thank you guys for your time, and I hope that the session was fruitful and useful, not just to the students, but even to the industry professionals. Yes. Yeah. And I hope that we can meet again next week. We'll invite you guys, the professionals, to come and witness these guys decoding the bytes and telling you that M3UA has 10 parts, and these parts look like this. And they can showcase in a few weeks that I can write code to actually get those things, and I can bring those links up and the associations up. Is that okay?
Yes. Thank you.
Yeah.
That was
Thank
sour.
you.
Thank you. Yes.
That's fine.
Yeah. Asanteni for allowing us to extend a bit, but I hope it was useful. And the guy from Copycat, Henry, asante sana. At least you have acknowledged you came because of the summit. We really appreciate it.